next section, sorry, 5.4, indefinite integrals. And we will pick examples and the net change theorem, but I need to talk about the indefinite integrals first. So we have two types of integrals. Definite, the answer is always a number, always. Again, how does it look like? The integral from a to b, any constants, f of x dx, and this has to be a continuous function on the interval a comma b. The second type of integral is indefinite. An indefinite integral will not have limits of integration, and it will not be a number. So it's the integral from f of x dx, which will always be a family of functions, infinitely many functions, nothing else but the most general antiderivative. So this will never be a number. This I can never check. I can only hope that the correct answer is 10e of that. I don't have a way of checking, just going through it one more time and making sure that I didn't make an error. However, this is very easy to check. Whatever function I get plus a constant, I can always check. How do I check? Can anyone give it a shot? How will I be able to check an indefinite integral? Which process will I apply in order to check that the left-hand side equals the right-hand side? It's Fundamental Theorem of Calculus, Part 1. Yes?
You take the integral of it?
You mean differentiate?
Differentiate.
Right. What do I get on the left-hand side?
Just f of x.
Exactly. What do I get on the right-hand side? The antiderivative prime must be f of x. And we will choose examples and check several, the ones that you would like to check. So the indefinite is always nice. I can always differentiate this to make sure I get that. But here I can never check. I can only hope that my answer is correct or go back and redo it. Good, so I like to practice finding indefinite or evaluating indefinite integrals. I'm going to share my screen so you can pick. Anything. Anything. Find a general indefinite integral.
Can we start off with like a polynomial style one?
Yes, anything.
Maybe like...
You choose.
Stop scrolling.
Sorry.
5. Yeah, 5.
5, very good. Nothing is new here. You understand, it's nothing new. We've done this from section 4.9. We just didn't use the symbol of integral. So everything is the same. So 3x to the third over 3 plus 4 x squared over 2 plus x plus a constant c. Done. So this is not new at all. Yes, I'll simplify and write x to the third plus 2x squared plus x plus a constant c. And let's say I don't trust my work. I want to differentiate this. 3x squared plus 4x plus 1, and I have to get the function. So we did not talk about this in 4.9, but this is what we did. We determined the antiderivative. I couldn't tell you at that time in 4.9 that we're really determining the indefinite integral. Now I can. So please choose anything you like from 5 through 24. Tell me where you want to stop and we'll stop.
About 20.
Very good, 20. Let's start with 20. I wanted to do 17 before 20, but if you allow me, if that's okay, and then I'll copy 20. I'll copy 20 on the side as well. So the integral from 1 plus r over r squared dr. And I'm copying the integral from e to the x plus 1 over x dx. Because of something we did in the past, when we looked at natural log of the absolute value of x, and we differentiated this, we got 1 over x. And at that time I said, when we apply the integral, which we didn't know at that time, to both sides, so if I'm asked to find the indefinite integral of 1 over x dx, I have to write this. Natural log of the absolute value of x plus a constant c. Okay, very important. Good, so then this integral is e to the x plus natural log of the absolute value of x plus a constant c. If I want to differentiate this, when I differentiate I get e to the x. When I differentiate this, I get 1 over x. When I differentiate the constant, I get 0. Good, so now let's look at 20. The integral from 1 plus r divided by r, everything squared. So the r, of course, I have to simplify this function a little bit. I can write 1 over r plus 1, or I can just square and then separate into 3 fractions. It doesn't matter. One or the other, I have to simplify the function. So let's do it aside. So 1 plus r squared is 1 plus 2r plus r squared. Square the denominator as well, so it's r squared. And now I have to separate into 3 fractions. I'll start in the correct order. This over this is 1 plus. This over this is 2 over r. And this over this, I'm going to write plus r to negative 2. So I have to simplify as much as I can in parentheses. So I square the top, I square the denominator, and then I simplify by separating into 3 fractions. This over this is 1. 2r over r squared simplifies into 2 over r, and 1 over r squared simplifies into r to negative 2. So now I can write the answer as the integral first of 1 plus 2 over r plus r to negative 2. Everything dr, of course. And I can write at this point the integral, so I'm continuing here, so you know where it is. R plus 2 natural log of the absolute value of r plus r to negative 2 plus 1 over the same number plus a constant c. So r plus 2 natural log of the absolute value of r minus 1 over r plus a constant c. When you differentiate this, you have to get this function. Otherwise, the answer is incorrect. Very good pick. Let's see if we want to work on anything else. Anyone else? Let's look at 16. So the integral from x squared plus 1 over x squared plus 1 dx. Okay, ready? Okay, can anyone give us an idea how to start? Or what will be the most general antiderivative? What about x squared? What do I write for x squared?
x to the third over 3.
Excellent. What do I write for 1?
X.
Good. Plus, what do I write for this?
Is that arctan?
Thank you very much. Done. Anything else we would like to look at? Anything else?
Could we do one with logs?
Yes. As the integral of log?
Yes.
Very good question. Sorry. I need the integration by parts. So we cannot do that. Unless we use a substitution. But just this, it's not possible at this point for us. You have to wait till the next class. Okay, we will see some in the next section, 5.5. Okay, maybe we want to go back to some definite integrals. I don't know why they go back here to more definite integrals, but we can choose from these.
Can we do number 40?
Yes, let's start with 40. Same thing with 40. We have to break it up and fully simplify the integral from 1 to 4, the square root of y minus y divided by y squared dy. So again, we're going to have, I'm sure we're going to find integrals that have natural log, but they have something else that allow us to use a substitution. The integral, definite or indefinite, from simply natural log, we cannot. We have to use integration by parts for this one. Okay, it's a technique of integration. Okay, so again here I have to separate the function. So the square root of y is y to 1/2. So y to 1/2 minus 2, and then minus y over y squared. This is 1 over y, and that's nice. Yes, from the very beginning I should have asked, is this function continuous on 1 to 4? Yes. It will not be continuous at 0. It will not exist for less than 0. So everything is safe. I can use the fundamental theorem of calculus, and this is part 2, right? Because it's a definite integral. Good. So then I have 1/2 minus 2 is -3/2. So y to -3/2 plus 1 over -3/2 plus 1. And then this one is minus natural log of the absolute value of y from 1 to 4. So the antiderivative of this, since the power is -3/2, it will be -3/2 plus 1 over the same identical number minus natural log of the absolute value of y. And you can say, but you don't need the absolute value because we're talking about numbers between 1 and 4. Correct. But initially I have to write it. It's not necessary as long as they are positive numbers, but they could be negative numbers. I could have from -5 to -6, or -6 to -5, it doesn't matter. But then I have to use the absolute value. Here I will drop it after I put 4 and 1 in there. Okay, so let's continue. And so this is -3/2 plus 1, which is -1/2. So I have to flip that into -2 because it's 1 over -1/2. And then the top is, again, -1/2. So this will be y to -1/2. And then minus natural log of the absolute value of y, again, from 1 to 4. Perfect. So I plug in 4, so -2. when I plug in 4, so this is basically 1 over the square root of y. So y to negative 1/2 is 1 over the square root of y. So this will be times 1/2 minus natural log 4. Now minus, careful, when I plug in 1. So this is 1, so it's negative 2, and this is 0, minus 0. But be careful with the negative, because this comes from the fundamental theorem of calculus, and if you forget, you can distribute it by not putting parentheses, but if you forget to distribute, then your answer is not going to be correct. So negative 1 minus natural log 4 and plus 2, because this is 0. So 2 minus 1, 1 minus natural log 4. And that's the final answer. So more